Earlier missions had found that liquid water existed on Mars, in the distant past. Perseverance's older cousin, the Curiosity rover, explored the habitability of Mars. It found nutrients and energy sources that microbes could have used, and established that Mars indeed had regions that could have been friendly to life in the ancient past. Did life take hold on the red planet? Perseverance takes the next step by looking for the signs of past life itself. Perseverance is set to explore Jezero crater. From orbit, this crater shows all the promising signs of a place that was likely friendly to life in the distant past. The rover's goal is to study the site in detail for its past conditions, and seek the very signs of past life. Its mission is to identify and collect the most compelling rock core and soil samples, which a future mission could retrieve and bring back to Earth for more detailed study. Perseverance has 4 main science objectives. Geology, study the rocks and landscape at its landing site, to reveal the region's history. Astrobiology, determine whether an area of interest was suitable for life and look for signs of ancient life itself. Sample caching, find and collect promising samples of Mars rock and soil that could be brought back to Earth in the future. Prepare for humans, test technologies that would help sustain human presence on Mars someday. Perseverance rover will carry 7 primary instruments. Mastcam-Z, an advanced camera system with panoramic and stereoscopic imaging capability, and the ability to zoom. The instrument can also help scientists assess the mineralogy of the Martian surface and assist with rover operations. Mars Environmental Dynamics Analyzer, a set of sensors to provide measurements of temperature, wind speed and direction, pressure, relative humidity and dust size and shape. Mars Oxygen ISRO Experiment, an exploration technology investigation to produce oxygen from Martian atmospheric carbon dioxide. Planetary Instrument for X-ray Lithometry, an X-ray fluorescence spectrometer with high-resolution camera to determine the fine-scale elemental composition of Martian surface materials. Pixel will provide capabilities that permit more detailed detection and analysis of chemical elements than ever before. Radar Imager for Mars Subsurface Experiment, a ground-penetrating radar to provide centimeter-scale resolution of the geologic structure of the subsurface. Scanning habitable environments with Raman and luminescence for organics and chemicals. A spectrometer to provide fine-scale imaging, and use an ultraviolet laser to determine fine-scale mineralogy and detect organic compounds. Sherlock is the first of Raman spectrometer to fly to the surface of Mars, and will provide complementary measurements with other instruments in the payload. SuperCam, an instrument that can provide imaging, chemical composition analysis, and mineralogy. The instrument can detect the presence of organic compounds in rocks and regolith from a distance. This instrument also has a significant contribution from the Centre National d'études spatiales Institut de Recherche en Astrophysique et Plantologie France.